Let me work that. Okay, thank you, Philip. Right, so my name is Nicolas Gagnon. So you will have been exposed to a lot of French-speaking names this morning. Philippe Couture, Nicolas Gagnon. So it's a good thing to present this morning. Thanks for the opportunity. For those who don't know Exfo, we do test orchestration and service assurance and monitoring, 3D analytics monitoring solution for customers that are looking to test, monitor, and do service assurance over fiber, medium, and fiber service. So I was hearing yesterday Mr. Jagley talking about FIB when he was mentioning DWDM, optical white box, things like that. I was very happy because that's definitely my domain. My domain of expertise is not, let's say, peering, it's not BGP, it's not everything. It's more physical layer to layer 4, depending on which model you use. But I really believe that you guys, even if you don't touch necessarily or work with the fiber medium too much, it's definitely where the industry is going. It's not always in fiber to the home and things like that, but definitely there's bandwidth pressure and fiber is there to stay and to face the music, if I can say. So let's start with that. So, well, bandwidth pressure. If we're looking at the data center, metro network, and even data center interconnect network, all these fiber segments are put under pressure. As you see on the slide, you see many links, let's say a combination or a patchwork of 1 gig, but most of the time in major data center, it starts at 10 gig to the port, to the rack, okay? Going to the main distribution area, where people leverage 40 gig, more and more 100 gig, getting out of the data center in wide area network or data center interconnect, where 100 gig, mainly coherent-based transmission, is widely deployed these days. And some of our customers already work in this portion of the segment, of the network, sorry. They plan 400 gig as we speak, okay? All the speed is very intimately related to the transceiver technology. The more transceiver technology that comes in the market, and this year we're seeing a lot of transceiver introduced, PSM4 that will be good over single mode fiber, up to optimized for 500 meters, PAM4 that will be used in the DCI up to 80 kilometer to, let's say, make an alternative to the more costly coherent-based transmission transceiver. So as more transceiver you see coming from the industry, people adopt that because there's a big bandwidth push and increased requirement. One thing is interesting to understand also, and that's this portion here. Probably that you guys will not be surprised about that. But when I speak to more people that manage fiber, they are not, well, they are all surprised or impressed. We see, as I said, a big push for bandwidth requirement. Cisco VNI tells us in the last February report that 5 zettabytes of bandwidth global data center traffic worldwide is the amount of bandwidth that is running everywhere on the networks, inside the data center, outside the data center, to the customer in 2016. This volume will double in the next 3 years to pretty much 10.4 zettabytes. But the most important thing to understand is that this traffic is 75% or 73% confined inside the data center. It's rack-to-rack transmission. The like you put on Facebook, not to promote this only service, but before people see that on their page, on their feed, it just update all your friends' pages, and that's a lot of traffic that stays inside the data center. So this amount of traffic, 70%, 73%, sorry, within the data center, 10% only DCI between the data center, and a little bit less than 20% that goes to the DC user. So that's definitely Where will we see, or where are we seeing today more bandwidth pressure? Inside the data center, definitely. So 100 gig or migration from 10 gig to 100 gig will be a very big topic of discussion and activity in the next few years by colos, by web scale company, everybody that runs data center, that of course needs peering, DNS management and everything, but that needs a very proper fiber infrastructure. Okay, this slide shows that I was talking about transceiver. The industry has developed two main categories of transceiver that are called or coined parallel optics based on MPO connector. So MPO to the transceiver are parallel optics. Parallel optics can give some benefits. You can break out and bring some bandwidth to different pod or racks without top of the rack switching, without aggregation. Everything is done at the server, at the physical fiber optic layer, and with optical card or optical port on the server that we see more and more, you can run up to the server with the parallel from the main switch at the entry of your data center. I'm breaking this out. So that's the scenario number 3 on the picture. And you have also the scenario number 2 that is more, a little bit more for 40 gig or 10 gig that use always the same MPO backbone cable, but that will use MPO connector to the transceiver in the switch. The other category is more what I call the WDM optics or the serial duplex. It's going to be the same speed, 40 gig, 100 gig, 10 gig, but the big particularity is that you have LC connector on the transceiver and you do transmit and receive over 2 fiber. And if you leverage, like in the CLR4 scenario transceiver, then you will use WDM to have 4 times 25 gig line rate, per instance, and provide a 100 gig interface on the transceiver, LC duplex connection to the different other switching element in your data center. Leaf spine. I believe you know that very well. This architecture has been proven to scale, to be very effective. I present this slide not to tell you or educate you about the leaf spine, because I believe that everybody knows in the audience what it is. But I just reinforce the point that you see a bunch of black box with patch panel that makes a lot of connectors that can be manipulated. And when you manipulate a connector, it's basic, it can be contaminated. Contamination on connector, it's, according to our source, 90 to 95% of the issues you will find on fiber optic infrastructure. Because most of the time people don't have the proper equipment to inspect or clean, but most importantly, they don't have necessarily the right training to know that they can do a lot of damage if they take the connector and they just gently sweep it on a finger. Oil contamination is a very big issue in data center. Before to extend a little bit on the inspection and contamination, I just want to present this slide to put, again, for a basic test of measuring insertion loss or optical return loss or reflectance. That's parameters that you need to test sometime at the construction, sometime at the upgrade of the network, sometime in troubleshooting because something went bad and you want to know where it comes from, okay? Then you need, I say, basic testing tools, physical layer tools to test the fiber optic medium like OLTS or OTDR. And everything I present here is very generic. You see the blue product that are associated to my company, but we're not the only one that sell OTDR, OLTS, or things like that. So I built this slide pack to be the most vendor agnostic possible to elevate the discussion and the education. So what I want to put everybody on the same page, if you're not there already, is that you have the OLTS on the bottom, and you have the OTDR in the bottom. First thing, when you use an OLTS, you need 2 units. These units are light source, power meter. Sometimes OLTS, well, OLTS by definition integrate the light source and the power meter, both elements inside one tester. Then you can do bidirectional loss measurement. It will measure the length of the fiber also, according to the standard. And according to the standard, because the standard gives you some value for some physical layer standard or IEEE service standard, it will tell, and these information are encoded in the tester, that for such a line rate with multi-mode or single mode fiber, you cannot go over such a distance or such a loss budget. Then the unit will tell you, or tell to your contractor, a big pass or fail, green pass, red fail, diagnostic. Easy to understand, and then it's easier to troubleshoot the issue after. So again, OLTS 2 unit, you can do bidirectional, and this one will give you the total insertion loss and total optical return loss. Some does. It will never tell you where the mapping of the fault is. The OTDR on this side works with 1 unit. It's like a radar. Sends light and receive the signal that comes back. And the signal that comes back because of impurities on the fiber or bad connection somewhere. A bad connection at the panel may create a big reflectance, minus 30 dB of reflectance. It's not good at all. I'll come back to that. It can create issue. So the OTDR, and if you want to measure properly the first connection and the last connection, you need to use these launch and receive fiber tail. All the OTDR vendor ask you to do that. It's a proper methodology to characterize the input and output connector. If you just want to troubleshoot and you are interested to know where the break can be on the fiber and not get the real precise measurement of the entry and output connector, you can plug a very short fiber there, right there, and you will get the break if there is a break somewhere. But if you care to measure the connection there, you need to use this launch and receive, okay? So the fame to glory of the OTDR is that it can map the issue. And one best example is, what is the back reflection at this patch panel that can, instead of going at this switch, it can go out of the data center, and if there's a too much big back reflection there, an EDFA can stop working. Automatic power reduction mode drops the power for safety reason. If this, by example, back reflection is worse than minus 30 dB. Okay. So here, what I present is I still take the sleeve spine example. In this example, the blue, let's say, connection you see on top can be copper. So fiber begins at the leaf switch, the head switch, to the core switch where you see spine in the bottom. So this use case represents something very typical that people need to do in data center: move, add, and change of transceiver. If you change 1,000 port of leaf switch and spine switch in a migration to 100 gig or 40 gig, you have a bunch of transceiver to install, you will find some issue at a certain statistical percentage inside this pool of transceiver. So the best way to, let's say, achieve this migration effectively is to get a method of procedure. The method of procedure that we recommend is quite clear and simple. If you touch a connector and you disconnect something, inspect with a probe. Okay? Then you will get a pass or a fail on the instrument or on the interface, because each time you manipulate, you can contaminate. Keep that in mind. Train your people to do that. And before to inspect, you disconnect, but you test the whole link with an OLTS. You don't expect an issue. You just want to validate that this permanent link or this channel link without the patch cord is good and in the budget. And you do that for one reason, and you want to do that very quickly, and that's why the OLTS is the best technology, because it tests that link in 3 seconds, 2 wavelength. The use of 2 wavelength will help you to diagnose if you have a macro band, for instance, and it will validate the budget. Once the permanent link is clear and you know it's good, then you move your transceiver, and if you have an issue on the transceiver, you don't ask yourself if it's the fiber or the transceiver. The fiber has just been validated. That's this kind of method of procedure that saves, at the end, a lot of time. Okay? So that's another use case. In this use case, it's more at the construction. When you construct these permanent link and you want to follow the standard recommendation, the TIA 568 D-3, for instance, tells you, don't test the link, the total link. Test the individual permanent link. There's one reason to that, because this standard favorizes the OLTS, and the OLTS cannot map the fault. So if you do something more complex than just one basic link, you have more chance to have issue that you cannot map. So actually, you can use the OLTS if you follow the standard that I said and you test individual permanent link. OLTS is good. OTDR is good also, because you want to test the permanent link, including the connection. You need the launch and the receive, as I said. But what we promote more and more is, if you go with OTDR, because this one, whatever the vendor, by the way, because the OTDR can map the fault, each and every connection, you can, let's say, take your receive cable, bring it here, and test your complete link. Then you map each and every connector position, and that's the power of the OTDR. I mentioned MPO briefly at the beginning of the presentation as one of the two, category of transceiver made by the industry was using, one of these two was using MPO, MTP. You all understand that MTP, MPO are multi-fiber connector. The industry use that right now either in 12 or 24 fibers. 24 fibers is 2 rows of 12. And this connector is compliant, if I can say, for single mode and multi-mode fiber. Okay? So if we're talking multi-fiber, aligned precisely in a row, it's very important to have, when you connect these two elements, the male and the female, you need to have a good physical contact. And that's the reason why we have pins, guiding pins and guiding holes, to really assure the perfect physical layer, not physical layer, but physical contact, and the alignment of the 12 fiber in between. So that's the point here. You have the, let me do this extra animation here. If you have a good physical contact on your MPO, if the guiding pin and the guiding hole are well aligned, if you create multiple connects and disconnect, you will increase the tolerance of the mechanical elements. So you're going to begin to have more insertion loss. you're going to begin to have return loss that will go back to the laser that can unstabilize the transmission. MPO is a very good connector because it gives very nice density, and it's ease the installation of 12 fiber or 24 fiber at a time ribbon. But when it's in a backbone behind the racking, connected one time, clean properly at the connection, and never disconnected, no problem. If you begin to bring that to the transceiver, and you do a lot of move out and change of transceiver on the same channel link that goes inside this transceiver, you will have issue. You will begin to see reflectance issue. And one of the big trend of these connector is the migration to 100 gig. 100 gig, especially with 25 gig lane rate on each fiber, is less tolerant to reflectance than 10 gig lane. And we are kind at a cornerstone in the industry. People migrate from 10 gig lane to 25 gig lane, and they see some kind of issue of reflectance at connection points and panels. So it requires some kind of testing or troubleshooting consideration. I was talking MPO, of course. You see here a nice 24 fiber multi-mode connector. These connector needs to be inspected, of course. The industry came out with tip on the probes of different vendors that can do that job. And you can inspect each and every fiber as you see on the picture on your right, actually. And different vendor have different options. You can go up to 400x times magnification. You have very easy to use auto center, autofocus product on the market, and these connector can be inspected such as single LC with a different tip. That costs a little bit more money, but because there's more mechanical parts, but that's as easy as the single fiber. MTP MPO cable configuration again, they come in different polarity or pinout, okay? So this is another test consideration that you have if you use this technology, or your contractor will have to test, because you need to make sure that if you use a type A, fiber to fiber straight, no reverse, it's connected with the same type cable extension, because your fiber one from one side will not reach what it should reach if you connect by mistake, or your contractor do, a type A with a type B. So before to connect these components, you need to validate the pinout or the polarity. Simple as that. There's a solution for that on the market. Another big trend that we see, of course, for those who go with the parallel optics, that means MPO connector to the transceiver, and that they want to do more than 40 gig, 100 gig. That's exactly the PSM4 type of transceiver I was talking about. So what people buy from different cabling solution vendor, pre-terminated fiber infrastructure, they receive that. They want most of the time to do a pre-installation assessment, because these pre-terminated infrastructure, what is between the point one, whoops, sorry, what is between the point, I'm gonna get there. These pre-terminated infrastructure comes on pallet on the reel, and the transport you can have some issues, so people want to do a pre-installation testing stage using OTDR to see if something is break somewhere along the fiber. They install it, and after the installation, to make sure that any fiber has been kinked or bent or damaged, they do again the installation, again with the same OTDR, to see if the installation stage has induced issues, okay? And the industry has come up with companion for these OTDR, MPO switch, namely, as you see here, then you can convert the power of the OTDR to the MPO interface. So that's very easy to use. And of course, you have the different launch and receive that are used to characterize the input and output connector. So as you may remind that the slide before, there was 3 big number green on the bottom. It was 3 connection point. That's what you get when you test with an OTDR and an MPO switch. That's what you see. This is the lead, this is a switch. This is a launch fiber. This is the first connection point, second connection point, third connection point. For each connection point, you will be able to get the detail of the insertion loss, the reflectance. You will have the accumulation of the total loss on the link. OTDR is very powerful. You get all these details, very easy to interpret, and you get a summary of each fiber on this connector, provide you a pass or a fail. And in that case, there was 11 good fiber, 1 bad fiber. This fiber here that you see was good, but you see a fail on the top because that's the other fiber companion on this connector that was a fail. Okay, so, yep. I was talking about back reflection a little bit earlier in this scenario of migrating from 10 gig to 100 gig. That is an issue that we see since a couple of years with people that have started to deploy 100 gig coherent then, and that's, let's say, what we continue to see with those who start the installation of the first shipping, if I can say, of the PSM4 on 500 meter in single mode. What I present here is the result of an application note that we did. The reference is there. Yeah, I will explain. We did 19 connection, mating of connectors, okay? For each connection, we took 4 samples of data for each of the 19 connections. The sample of data were contamination at different wavelength. So clean connector at 1310, clean connector at 1550, dirty connector with finger oil at 1310, and dirty connector at 1550. And we measured the insertion loss, which is a very popular parameter for qualifying the quality of the installation of fiber infrastructure. What we see is a strict correlation for each connection, okay? Each connection are created equal, are not created equal, sorry. So each connection can vary from 0.2, 0.15 to 0.6, of course. Everybody understand that? But for each connection, we have a very strict correlation for the 4 sample, okay? So one nice correlation, as we see, presenting different insertion loss performance for different connection, 19 sample, 19 item like this. Normal. What is happening if we look, instead of looking at insertion loss, if we look at return loss or reflectance, that's the same thing, okay? And as I said before, reflectance is more important if you deal with higher wavelength, higher line rate, sorry, or higher speed interface, 100 gig, namely, and it will not be different in 400 gig. The same 19 connection, the same sample of contamination, but 2 different correlation. The clean one are straight, always higher 55 dB of reflectance, no issue there, all green lights, no problem. And the dirty one, those who have finger oil on the end face of the connector, it's systematically 10 to 12 dB more issue, more reflectance penalty, okay? Just for finger oil. On 19 connection, strict correlation of contamination, and where you see the red spot, it's because I took the liberty to identify 6 connections out of 19, 30% of the sample, that are below 45 dB, minus 45 dB of reflectance. Why minus 45? Well, the standards tells us that the components standard, the 801 IEC or the TIA 568 tells us for single mode, because this was single mode, by the way, 35 dB is the parameter, the level of reflectance you need to look at before to cry out loud, okay? And that's a lot of reflectance. So the other standard identified 45 dB. That's pretty much what I see as a good target. And some customer discussion told us, if you deal with coherent, at minus 30 dB, as I said before, you have APR issue, automatic power reduction mode from the EDFA, that will create a lot of issue on the transmission signal. Or the direct modulation type of transceiver, we look at minus 40 to minus 45, pretty much like this. So again, in this experiment, 30% of the connection contaminated, created big issue based on these thresholds. Yeah. Other issue that people face a lot in the data center. I mentioned that you do a lot of move out and change of transceiver. And okay, you can get the procedure I have recommended before, validate your fiber. If you have an issue, you will know that it's not the fiber, it's the transceiver. But if you have an issue with the transceiver, you're not more advanced. You don't know what the issue is. So the industry has came up with some solution based on service, on module that tests 100 gig performance, and software application that will check the quality of these transceiver or high-speed pluggable, giving quick pass-fail verdict based on a less than 3-minute test that will do a sequence of 6 tests, looking at the power consumption, the temperature, the skew, and not for load test of 72 hours, of course, 3 minutes. You just want to know if this transceiver is good or bad. And when you have to install thousands of transceiver, it eases, let's say, the communication with your vendor to get a tool like this that gives you more information on what are the issues. Is it, as we see here, one lane that doesn't appear, or one bad lane, or things like that? The tool will tell you that, providing you a verdict, pass-fail, of the quality of this transceiver. I'm more in the DCI section of the talk right now, the data center interconnect. And I bring to the table, or on the presentation slide, one important topic, network latency. It is more and more an issue. Data center people are strategically mapping the construction of different data center to reduce the distance to their main market. Why? Because fiber itself induces latency. If you run over hundreds of kilometers of fiber, you will have a native latency you cannot hardly reduce, okay? You just need to bring your data center closer. We cannot put data center in each home of each subscriber, of course, and on top of that, different application. One of the best example is the trading desk for the financial people, where portion of millisecond means millions of dollars of profit in trading, okay? So latency is a big issue. You need to control that. You need to measure that, and you need to reduce that. But before to talk about key performance indicator of the service itself, like latency, packet loss, bandwidth, QoS, bit error rate estimation, things like that, you need to make sure, if you deal with your data center interconnect, that the physical layer itself doesn't bring any issue, okay? So you need to, especially when you rent fiber from people that cannot tell you when it was constructed, cannot tell you what type of fiber. Is it G.652, G.657? Is it a mix? Is it a patchwork of fiber? Ask them, do you have chromatic dispersion and PMD data for me? Look at their face, okay? Our customer ask this information to, let's say, people they rent dark fiber or lease fiber, and most of the time they decide to invest themselves or contract people to do the test themselves to get the information. Because at the end of the day, it's your subscriber that will feel issue on the key performance indicator most of the time, protocol layer, created by physical layer issue baseline, okay? So you need to do CD, PMD, in-band OSNR or OSA characterization if you use DWDM or things like that, or EDFA. And when it's clean, when you know there's no problem, of course, then you go to service activation testing. Talking about service activation testing, before to do that, you need to, well, one good best practice is to make a bit error rate evaluation, okay? Layer 2 test, traffic of the validation of the traffic on the link. You estimate the bit error, and then you know that the first, let's say, layer of your protocol stack is clean when you have validated before that the physical was, okay? Then, after the BERT, of course, comes the more service activation method-oriented testing, multi-service Ethernet testing, service activation methodology based on Y.1564 of the ITU-T is a good example. TCP throughput test. It's not everybody that has that, but some people, financial and big data user, want to be sure of the throughput, and they want to get some visibility on this testing based on the RFC 6349, okay? And for a portion of the people where timing is very important, it's not 100% of the market, of course, but Sync-E, based on 1588, is another type of service that can be done on the service activation level. And because you have many services on this fiber, you need to test these parameter or tests on each class of service. That's important. And one best practice is always to test from 10 meg to the committed information rate, the CIR, okay? If you go at 100 gig, 10 meg to 100 gig. If you go lower, 10 meg to lower, okay? And again, the industry have solution for that. Okay, last two slides, I think, and we're good in time. I'm switching now a little bit more to the monitoring portion of what the industry can benefit in terms of type of testing. This use case is typically the data center. You can have a very big benefit to do intrapod, interpod, inside the same data center or inter-data center type of monitoring to characterize all the layer 2, layer 3, using layer 2, layer 3 technique and measuring the mesh performance between all these probes, across all these probes. So that's one way to see the thing. It generates a lot of data, but again, the industry come with dashboard, analytics, and all that to help you find what really matters inside all the data that are generated. And, well, last but not least, and well, it applies to the next slide, but I'm gonna tell it that there. You don't need necessarily to install hardware-based probe. The industry came in the last few years with virtual probes that you can install on your own server that reduce the cost of the deployment significantly. I'm getting a little bit out of the data center here. I'm more in the data center interconnect. Data center operators that have more than one premise, one building, sometimes separated with serious distance or big distance, sometimes intercontinental, thing like that, will get a lot of benefits to measure the performance of, let's say, the service they provide between their infrastructure, outside of their pod. Again, in different category of service, if you provide voice over IP, IPTV video, over the top, IP, VPN service, Skype business is a good example also, very popular these days inside the data center community. Help Microsoft or other company to provide this service. And what we can understand from some discussion we had with some people, the people that, let's say, house this service and provide it to different region can gain, or, well, they gain to know the quality of experience they provide to their subscriber. Let's put it that way. And that's where, let's say, the industry came up with, let's say, a mix of passive probe and active probe. An active probe helps to perform some emulation of service. So you can emulate voice, video, web, transaction or streams, and capture the quality of experience performance as your subscribers see it, because it's kind of a test stream that you're monitoring and everything, generated by a virtual probe or a hardware-based probe inside your network. So accumulating data with passive probe is interesting, but simulating traffic and doing the same, measuring the performance scenario that your customer or subscriber see the service is always very good. Because at least if some people complain, you can reproduce this kind of behavior in some portion of your network, so you get a better visibility. So that's pretty much it for me. 2 minutes before the time, or 2 minutes 30 seconds. Just take the opportunity to invite you to a LinkedIn forum that we started, vendor agnostic, always. We want people to share concern, ask question, things like that. And it's open to the competition. It's managed by Expo, but it's, again, vendor agnostic. So go there. If you love what you see, I invite you to subscribe. And I hope that this talk was instrumental, that you learn a bit of things. I'm going to be here for the rest of the week. So if you have discussion, if you want to chat about some things, ask question. It's going to be my pleasure to discuss with you later today or tomorrow. And if we have a bit of time for question, that's pretty much where I am. So thank you so much.